goes question like this. For two ionic solids, they have mentioned that these both are ionic solid. One is calcium oxide, other one is potassium iodide. Right? Which of the following statement is false? First thing, lattice enthalpy. Let us talk about something like this, right? So see, first of all, the given compounds are ionic in nature. So these are ionic solid. So both here I have calcium oxide and here I have what? Potassium iodide. Right. So this calcium oxide, if I write it in terms of ions, it will be like Ca2 plus and here O2 minus will be there. And this potassium iodide, K plus and I minus iodide. Right. So this is the ionic structure of these solvents. Right. So we should know that if the charge on cation, charge on anion are more, they form a very good lattice. Means here Ca2 plus will be there, O2 minus will be there, Ca2 plus O2 minus, like this they form a very good strong molecule. O2 minus Ca2 plus, O2 minus Ca2 plus, right? So like this they form a very strong solid, right? Once they form strong solid, it means while forming, if they both react, they release so much energy that energy we call it as what? Lattice energy, right? Lattice energy or the lattice enthalpy. So they have told lattice enthalpy of calcium oxide is more than potassium iodide. Yeah, this is true. But the thing is, they have asked the false statement. We have to choose one which is false. Among these four, three will be true, one will be false. That we have to choose it, right? So the first option is true. This is true, not the false statement. Why it is true? See, I have told calcium exists as Ca2 plus and O2 minus. It forms a lattice such that its bonding will be very much efficient with the oxygen, so it releases more of energy. So it has got what? High lattice enthalpy or higher lattice enthalpy compared to this K plus and I minus, because here K plus is smaller in size, K plus is smaller in size and I minus is bigger in size. Its lattice will not be that stable, because see, here I have K plus I minus, K plus I minus, I minus K plus, I minus K plus. See, the bonding between these two will be not that good, not that efficient, right? So because of which it forms a lattice, no doubt. It is also any component forms a lattice, but the lattice enthalpy will be very less compared to this calcium and oxygen, because it forms a very good lattice, right? So the first statement is true. So we have to choose for the false statement. So this is ignored. So coming to B, calcium oxide has high melting point. So I have told, since calcium 2 plus and O2 minus form calcium oxide, it releases most of the energy. Release means what? Delta H is negative exothermic. It releases means it forms a very good solid lattice, right? So its lattice enthalpy will be more. The molecule whose lattice enthalpy will be more means it exists a very firmly solid state, and if I heat it, it should be converting into water, liquid state. So since it is very stable in solid state, because it has got high lattice enthalpy, so we have to heat it very high temperature, then only it is going to convert solid into liquid, that is then only it is going to uh, melt, right? So it has got what? High melting point. So the option B is also true. So but we have to choose the false option. So this is not the answer for us. So E is not the answer, B is not the answer. Coming back to C, calcium oxide is soluble in water, right? So if you have done this salt analysis there, for carbonate, CT, you do lime water test, right? So here if in the salt I have carbonate, to that you will add what? Lime water, CaOH twice. Then that lime water turns to milky. It forms what? CaCO3, which is solid, right? So its nature is what? Milky PPT will get it, right? So this is because of formation of what? Calcium oxide. And this is the lime water. Lime water is also called as slaked lime or lime water, right? So how this lime water is found means, if I take this calcium oxide solid, if I add it into water, that is liquid water, both react to form this lime water, CaOH twice, right? Both will react to form what? CaOH twice. It is what? Colorless liquid. This is what? Colorless. it doesn't have any color, it looks like water only, colorless, and it is aqueous, means aqueous solution will form. So calcium oxide is soluble in water to form what? Lime water, or the slate lime. So calcium oxide is soluble in water, so this statement is also true. So this is true, this is true, this is true, then first statement should be this one, right? So this is our answer. But before telling D is the answer, let us discuss why this is Ki soluble in benzene is false statement, right? So let us discuss. So Ki, they have mentioned that Ki is what? Ionic in nature, it exists as K plus and I minus, and we know that like, likes, like, in chemistry we use this statement like, likes, like. What is this like, likes, like? It means if I have a polar molecule will be soluble in polar solvent, right? So this you have to make sure. Polar molecules will be soluble in polar solvent, and non-polar molecules will be soluble in what? Non-polar solvent. So this thing you have to remember. And we know that potassium iodide is polar. Why it is polar? Because it exists like what? I plus, K plus and I minus. And this is benzene. Benzene, we know that this is organic molecule. Formula we know C6H6. It is like this cyclohexane. To that conjugations will be there. So this is nothing but our benzene. Benzene, here all are carbon and hydrogen, no polarity. So this is non-polar solvent. Whereas Ki is polar, and this is what? Non-polar solvent. So it is not going to dissolve in it, right? So it is insoluble. If I take in a beaker, if I take a benzene which is liquid, if I add Ki which is solid, it settles here, it settles like down here only. Ki, it is not soluble. Why not soluble? Because it is polar, whereas benzene is non-polar. In chemistry, what is the famous rule? Like, likes, like. Polar will be soluble in polar solvent, non-polar soluble will be non-polar solvent. But one is polar, if other one is non-polar, then both are insoluble. But they have given Ki is soluble in benzene, which is false, and they have asked the false statement. So this is our answer. D is the answer. Thank you.